Okay.
Better?
Yeah.
Well, that's not there. I have to fix that. But one of the things that I created was a clinic wait time app, which is in about 10 clinics in Las Vegas for healthcare partners. So what they had was pretty much a screen like this, and they had a really itty bitty tiny like estimated wait time for when you were going to see your doctor. And I took that upon myself to change that. And that was the first thing I created. I think I actually have a photo here. So I created it for that, but I white labeled it in React. And I should have a screenshot here. Yep. Vindicated. Here we go. So this had motion. This had like a little weather app on the side there. And this is something I was really, really proud of because number one, it was showing in 10 clinics. Like I could go into the clinic. I'm like, yeah, I made that. And it was very, very helpful because these clinics in particular were geared towards seniors. So when you see these TVs, if you don't think about it, when you're looking at this TV, especially for someone who's, cannot see so far or older people, they couldn't read the screens. So this brought a little bit more livelihood into it. You can actually see the minutes here, the thing that you actually care about. You know what clinic you're at, you know which providers are on here. If there were more, this would rotate through. And yeah, so this is something I'm just really proud of and wanted to show. And this is where I feel I really got a taste for what building something is and bringing it to fruition is and seeing it come to life. And I think that's the moment for me where I said, this is really, really freaking awesome. And I think I want to continue doing this job. This job, I was a junior .NET engineer at Healthcare Partners when I created this. This white label came way after though. So it's just to show you what it looked like. After that, I moved around a couple positions, learning something with each one. At one of them, I was underpaid. At one of them, I noticed I actually didn't like working from home if it's something I did not enjoy doing. And another one, I noticed I wasn't growing. So every jump that I made, there was something pushing me to do something greater. And right now, I'm at a place called Debt Trader. And what they do is everybody has debt, and I know it sounds ominous at first, but I promise it's actually a good company. Everybody has debt somewhere, payday loans, auto loans, student loans, mortgages, whatever you name it. And if you've ever received a letter where they say, oh, this company is now in charge of your debt, so that means all your payments go to them now instead of us, or it may have originated with Fannie Mae, Freddie Mac, but now it's being taken over by Great Lakes Loans or something. I got a ton of those, and now I know what's happening. Behind the scenes, usually these companies would sell debt to each other and buy debt from each other for whatever reason. I don't know what it is. Maybe they don't want to collect on these portfolios. Maybe I don't know. I don't know what the reasons are, but there is a marketplace for this where they buy and sell debt. And what our company does, the platform I work on, is making sure they do that in a compliant way. So we have a very rigorous compliance process. We have audits. We make sure everybody is vetted before they can join our network. And I was actually just working on something today where we have a module called post-sale. Pretty much after this sale has transacted, sometimes accounts either are, become bankrupt. That means they can't collect on it anymore. The person dies, so you can't collect on that anymore. There are all these different scenarios where they just cannot collect on these things. And this module that I was working on, we had to add another type. And if any of you have worked on legacy code that has not been touched for like 10 years, that's what happened today. So if you would think it's a function, and based on a type of that input, things change. And what needed to happen was to add 4 more types. And you would think that would be very easy, but with the code base that we have, that took about 4 sprints. That was very, very long. That should have taken 1 sprint. So that's where I am today. I love my team. I love my boss. It's probably the best team I've ever worked with. We all collaborate with each other. We can debate with each other without like getting angry or getting into each other's skin. It just focuses on the content, and I love this. I love this group. So if you guys are watching, I love you guys. So that's a little bit about me. The reason I'm here and I'm excited. So when BJ called me, he said you can talk about whatever you want, anything you want, as long as it's, I mean, it doesn't have to be related to JavaScript, but if it was, that would be better. We are JavaScriptLA. So I decided to talk about advent of code. And let me try to. Just so it's a little easier to read the screen. So what is advent of code? Advent of code is a program, or it's like an event that occurs every year. And it was created by this guy, Eric Wassel. I can open this. Oh, it just goes to his Twitter. So if you've ever heard of an advent calendar is something that happens around December, Christmas time. And usually every day you get a present, something. You know, if you had these calendars, you would see there's like a door on each day. And when you open the door, you got a chocolate or a candy or a prize or something. And it was just to help you get excited about, I guess, leading up to Christmas. So he took this concept and he created what was called Advent of Code. And it had 3 things that I need to be interested in doing something technical, which is gamification, collecting things, and puzzles. So Advent of Code has all of these 3. When I say gamification, you'll see here, I'll log in to 2018's, and I did not finish. There's 25 puzzles, because it's only until Christmas. So day 1 here. Every day he creates a programming puzzle that you are supposed to solve. It doesn't have to be JavaScript. It can be any language that you want, but it's a puzzle. You get some inputs, you get some tests, and you have to, you know, solve it to get an output. And day 1 is this really long thing. So he has this hilarious way of creating puzzles centered around like Santa Claus and elves. And so for this one, you know, oh, we've detected some temporal anomalies. One of Santa's elves at the Temporal Anomaly Research and Detection Instrument Station tells you, right? So each of these puzzles focus here, and this is where it gets interesting. So you are given examples, and you are given a puzzle, basically, in this story. And we'll get to it a little bit. And every day has 2 parts to it. So you'll see here, this is day 1, and this part here was part 1. There was my answer, and we'll get to that. And here's part 2. And if we go back to, you'll see here, there's 2 stars a day that you can earn. And every day, the puzzles get released at midnight. So if you are up and don't have anything else to do, or you're just really excited about it, want to earn those stars, like I was, then you can, you know, get there. And there's some really crazy leaderboards. Like people solve these in like 2 minutes. And for some of the puzzles, they get very complex. And I'm like, there's some kind of bot running here, or there's no way that you could solve it. But maybe they're just really good with data structures and algorithms. So you can get on a leaderboard. You can create private leaderboards. So like if you can't do it at midnight, you can make a little group, you know, where you are, and just have a private leaderboard, compete amongst yourselves. Okay, so all of that, and day 1. So I'm actually going to go here. So the reason I want to share this with you is because if you remember, I did my degree in management information systems. And at UNLV, that means half business courses and half like general technology, like networking, databases, a couple programming languages, things like that. And we did not go very well into data structures and algorithms. So I knew I was very weak in this spot, and I knew it when I would take some technical interviews. And every time I would ask to implement depth first search or binary, you know, something, I don't know. I'm like, I'm just not going to waste your time. I don't know this, but thank you. But I knew it was always scratching me in the back of my head, like, I'm very weak in this. I need to learn it in some way. And the only JavaScript experience I've had is, I don't want to be general in a generalization, but the only JavaScript experience I've had is directly with web development. So manipulating the DOM, putting text here, creating elements there, but nothing in terms of solving puzzles. So when I came across this and Advent of Code, I believe he has other years here. I'm not sure where they are. I believe this started, I think, in 2016. So if you want to go back, you can keep practicing there. But when I heard about this, I said, this is awesome. This is gamifying it, so it's a little bit fun for me. I'm very competitive with my husband, so he and I do this every night at midnight. It's me at my computer and him at his computer, and we're like looking at each other, and it's like, all right, it's released, and then we start coding to try to figure out what the answer is. So I love the fact that it's earning something, it's collecting something, it's collecting the stars. And even though it's a little silly, it comes back to my Pokemon days where I got to collect them all. So it really kept me going to come back every day to say, I got to get that star. And after I get the first star, I got to get part 2's star. And that really kept coming back. So anytime someone asks me how to practice their JavaScript, I always point them here, because it's not, I mean, HackerRank has its purpose, but the way that it gamifies it here, I very much enjoy. I like the star collecting aspect. The other part is that puzzles get consecutively harder. So maybe the first 3 or 4 days, I'm like, where's the hardness in this? I can do this. And as you can see, I tipped off at day 7. They get really complicated. They go way above what I have experience in, and I'll use the excuse, I have work, I have a day job, so sometimes I just don't want to do it. So all of that to say, I think you should check it out, and here's why. And I'll show you how I did it and how I implemented some things, how I used JavaScript, but also how I worked with this program to get started. So if you go to my GitHub, I have a repo called Advent of Code 2018. You can clone this. And you'll see here, the way I separated it out is by doing it day by day. So I created a folder for each day. And because I like to be concise, I just copied the actual question in case somebody can't go to the Advent of Code site for whatever reason. So it's here. And I think I have it here. So what I like to do for each day, I would name the file, right? So this would be part 1, and then usually the part 2 solution would be blah, blah, blah 2. And I'm gonna make that hopefully it's a little easier to read. I'd have a README, just again, to put that down there to remind me. But this is the important part here. That's the tests. And for each question here, you'll see that they give you examples. And these are very important. This might look better here. So you'll see here, for example, if the device displays frequency changes of +1, -2, +3, +1, then starting from a frequency of 0, the following changes would occur. So these are essentially your test cases. And that's what I did. I took each of these inputs and expected outputs, and I translated that into a test. So I think I'm just using Mocha here. And for the first one, interpolated strings here. So should return 3 when input is +1, -2, +3, +1. That's purely taking it out of here. Here are the situations here. And by creating these tests for myself, whenever I would come up with a solution, what I would do is I just run my test here. This is how I check myself. So I would come back here, I would code out a solution, run the test. obviously if there's anything failing, I know there's one use case that I'm failing on, that I'm not doing right. And this is essentially the workflow that I had going through Advent of Code. I would split it out day by day, create part 1, part 2, add the README, and got all of that, all of the commit goodness that we are all striving for on our GitHub pages. So for a while that went well, and as you can see, I tapered off at day 7. Either it's probably because it was really hard, but what I would like to do now is give you all a chance to read day 1, and you can tear apart my solution. My solution's not the only thing there. I don't want to talk about my code so much because that's one way of implementing it. I would like you to see, number 1, do you understand what's happening? If not, I would be more than happy to explain what is going on. Number 2, how do you think we could break down the problems here? And number 3, like, can you decipher which parts, which little smaller puzzles from this story do you think would translate to the problems that we'd have to solve in code? So you can just go to adventofcode.com, or you can read it here. I guess for here, I'll just read it if you don't mind. So let's see. Really, it starts from right here, right? So after feeling like, so you gives the intro, right? You're there, you got into this temporal anomaly of Santa Claus's elves, and you now have to collect 50 stars. Each puzzle grants 1 star. So here it says, after feeling like you've been falling for a few minutes, you look at the device's tiny screen. Error. Device must be calibrated before first use. Frequency drift detected. Cannot maintain destination lock. Below the message, the device shows a sequence of changes in frequency, your puzzle input. A value like +6 means current frequency increases by 6. A value like -3 means the current frequency decreases by 3. So already you can see these are the nuances of the puzzle that you got to solve. That obviously plus means you're adding here, -3 means you're subtracting. But that's not always the case in the other puzzles. But it's always good to read through it to get an understanding. That's probably the first thing that I really learned from here is you can read something and you think you understand it and you think you know what they're asking for, but you really don't. And that has happened to me every single time on every question here, because I would try to implement a solution and maybe 2 or 3 tests would fail for me. It's because I did not understand the question correctly. I just kind of sped through it and I'm like, oh, this is what they're asking for. So just it's fundamental, and I know you hear it all the time, but it really is just taking all of these problems, breaking them down into things that you really actually understand, know what they're asking for. And a really great part about Advent of Code is that not only do they do that for you by giving you sentences like that in the puzzle, but they give you the examples, your tests. So continuing it on, for example, if the device displays frequency changes of +1, -2, +3, +1, then starting from a frequency of 0, the following changes would occur. Currency frequency 0, that's where we're starting at. Change of 1, adding 1, resulting frequency is 1. Current frequency is now 1. You have a change of -2, resulting frequency is -1. So in this way, and these are the first puzzles, it's already kind of kickstarting your brain. It's saying this is like your nudge to say this is how you should be thinking of solving this particular problem. This is how, when you get these inputs, how you should deal with getting your output. And it continues on telling you what the resulting frequency is. So for this particular example, resulting frequency is 3. And here are other example situations. So +1, +1, +1. If that's your test input, your output should be 3. And I believe I wrote a test for that right here. So if +1, +1, +1 should return 3 when input is +1, +1, +1. So it's already pretty much helping you write your tests. Same thing, +1, +1, -2, it should be 0, -1, -2, -3 results in -6. So all of that, that gets you kickstarted, gives you the structure of what the problem is. And now it asks you, and everybody's is different. Everybody that logs in and signs up to do these has different puzzles. So you can't copy off of somebody else. Every puzzle is different. Every input, all your inputs are different. And obviously all your outputs are different. So this was my particular question. Starting with a frequency of 0, what is the resulting frequency after all of the changes in frequency have been applied? And where is my, here we go. So this is my puzzle input, and this is what's different. So you'll see here, there's no way to cheat this. This is your input. It's pretty long. I mean, you could sit there and add it and subtract it yourself, but since that's what we've kind of assumed, right, that's the implementation that they want you to do is if it's a plus, add, if it's a minus, minus. We understand that, and that would be the very, very tedious manual way to do it. Or we could do what was intended, which was build a solution to do that for us, because computers are better at doing that for us. So this was my input, all of that keeps going. And I believe I added that as well in my test, or I did not. See, so that's something I should improve. I can probably, oh, I couldn't add it as a test. That's right. I couldn't add it as a test because I don't know what the answer is, right? So I don't know what to assert that what it should be. So what I would do, coming back now to my solution here, so I would take the input, and my input here, sorry, this is moving in. So let's see. My input would be all of this. So this is my way of solving it. If you guys are looking at it like, oh, you could do this so much better, cool, do that. But I would pretty much start with my tests and get my input. So let's say test equals string. And that's very important here to interpolate that. The reason I use string interpolation is because the way the input comes matters in some of the higher puzzles, or the more complex puzzles. So here, you could fix it, you could, but sometimes the way that you get your input actually matters, and that affects the output of what you're trying to solve. So I have my input here. And you'll see I already, I would get my input. Where's my solution here? And this is my solution. So I don't know how familiar everybody is with JavaScript. I will just do kind of I guess a breakdown of what my implementation means, if that would be helpful. Do you guys kind of understand? Does everyone understand what's happening, or will it help if I went through what I'm doing in my solution? Yeah. Yeah. Okay.
So
go ahead.
That's what the on the DOS plate. Why you have like a backslash?
Right here. Yes. So this is to split on a new line. So this is the character for new line. So okay. So well, let me just remove all of this because that's just going to confuse everybody. Okay. So I created a calibrate function. That's what I called it. That's what this means. I'm declaring a function called calibrate, and I named it because of the name of the day, chronal calibration, calibrate. You can do solver, you can call it whatever you want. Obviously, it's going to accept some input, which would be this thing that's generated for each puzzle. And now we have to do something to it. So when we talked about what was, whoa, that's day 2. So when we talked about this, we kind of already understood it, right? We said if it's +1, or we add 1. If it's -1, we subtract 1. And I went along with that kind of train of thought. I said, I think I understand what's happening. It's pretty much giving me a whole list of integers, and it appears that I'm just adding them together depending on what it is. So that's kind of what I did. So the first thing I did was, the first thing I said I needed to do was I needed to break down that huge input that I got, all of these numbers, these. And the first thing I did was I split that. So that's why you see this. I split it by new line. So I'm grabbing each item there from my input. And with that, what I'm doing, because I'm not sure what it is, just to be extra sure, I'm using map to pretty much say, after I get each piece from my input, I want to try parsing it as an int, because the next part is either adding or subtracting it. Parsing it as an int, which is right here. And in the parse int function, it takes something as well as the radix, to what degree you want to parse this as an integer. So I'm taking each item there, I'm trimming it, because again, I don't know what my input is like. Maybe somebody had a typo when generating my input and there's a space there. Just cleaning my data, cleaning input. So I'm parsing it as an integer, cleaning up that space. And that's what I have now in my breakdown. And now I also have a total, which I'm using to keep track, because that's going to be the eventual output of my puzzle. And here, very rudimentary, just I use a for loop. So for every item in my breakdown, this sanitized, cleaned up data that I have, pretty much add it to the last item, and then return the total. And that's what I did. And that seems to work because my tests say so. So that's calibrate number one. That's part one. So what happens is I would, let's see, a little touchy here. So yeah, so I take my input, give it to the solution that I have implemented here, and run that, and this would calculate it for me, and this would obviously, well, not obviously, but when I would solve it, I would have this either return or, well, it's returning. I would console log a lot. That's what I do to debug and to find out these answers. But after passing my input into this function, I would get the resulting output of that. And if you see here, I've already solved this, so you don't see it, but let me go to one I have not solved, so you'd see what that would look like. So 17. So yeah, I'm already worried looking at this. I don't know. So see, all of this is just building the story of what you have to do, and this is your puzzle. So this is what it looks like. So before you solve it, you would get your puzzle input, and this is where you would get your answer. And the cool thing about this is, so let's say I'm going to make some stuff up here. Let's say I'm guessing 738 is the answer for this puzzle. That's not right. Of course not. Your answer is too low. So it kind of gives you a nudge that says, you're a little too low or you're a little too high. But the thing is, you can't keep brute forcing this. If you do, I believe it's 5 answers, you have to wait for, I think, an hour before you can answer again. So you can't brute force it. It really, not to be annoying, it just wants you to really focus to try to see if you can create a solution to solve it and get that answer. So, I mean, this has been there's like subreddits on this with people sharing how they've solved it, and obviously that digresses into, oh, you should have done it this way. So, but yeah. So that's part one. So let's go to part two. So can I see this? Okay. So I got the answer that I needed. Mine was 595, and that was correct. And it'll tell you, awesome, you're awesome, you got it. Here's your gold star. And I was like, yes, I got the first gold star. So after that, that unlocks part 2. Every day has 2 parts. And the second part is meant to be a little bit more difficult. So in the same vein, I'll read it and see what may be different. Sometimes it's only a slight change that you have to make to your solution. Other times it's completely different. Maybe using some of the same thinking that you did on your first solution. So we'll see here, all I see are more tests, so that's what I did. So I created a second function just because I want to separate out what I'm doing for each part. I added my tests for day 2. You'll see here, part 2. These are my part 1 tests. And so I added my tests, and here I'm ready to go. So let's see what this, so we'll see here, part 2. And bear with me, I haven't touched this in a while, so I'm just refreshing my own memory. You notice that the device repeats the same frequency change list over and over. To calibrate the device, you need to find the first frequency it reaches twice. So that's the goal there. For example, using the same list of changes above, the device would loop as, and then it walks you through what you should be thinking, how it should be going through when it's going through your implemented solution. So current frequency, you start at 0, you have a change of 1, resulting frequency is 1. Now your new starting frequency is 1, you have a change of -2, resulting frequency is -1. So you keep going, and then right here it tells you at this point, the device continues from the start of the list, keeps going, it goes back because you're at the end of your input. Current frequency is 3, change of +1, resulting frequency is 4, and then the last one, the goal that we're trying to get to, current frequency is 4, change of -2, resulting frequency is 2, which has already been seen right here. So in this example, the first frequency reached is 2. Note that your device might need to do this, all the other stuff, and some more test cases, right? So what is the first frequency your device reaches twice? And for each day, your puzzle input is the same. So there's no other, it's the same one. So out of this same list, go through this implementation it just talked about, and then tell me what's the first frequency that you've seen twice. So that's what I did. So calibrate duplicates 2. And again, I'm not trying to say I'm a JavaScript expert. I am not. The reason I'm sharing this is because I knew I was weak in it, and this was my way of practicing how to get better at it. Practicing, I didn't even know what split was. I didn't know what map was. I didn't know filter was a thing. I didn't know how to use the differences between object.keys or any of the array methods that are available to you. And when I found them and it fit what I needed to do for some of these, I was really, really happy because they said, oh, I don't have to do this from scratch. So this is me saying, you know, you may look at my code. I'm looking at it right now and it's really ugly to me. So, but it's a way to practice it, to get familiar with it in for me, a fun setting. It's the goal here is to get that star for me. The goal here is to maybe one day get on the leaderboard. That's going to be very difficult, but this is just a way for me to learn JavaScript. So again, I'll kind of go through my solution. Is that helpful? Was it helpful the first time? Will it help if I go over the second one? Okay. So my second function, calibrate duplicates, is what I called it. So same thing right here, familiar before. I broke it down. I split my input by new line. And for each item I got out of that new line, I am trying to parse it as an integer because I knew that there was some addition, some math we had to do onto it. So I want to make sure it's an integer and trimmed it just in case there are white spaces, blah, blah, blah. Cool. So now we have some clean input data in our breakdown. Let's see what I did here. So I have current frequency and a counter I set to 0. I have a duplicate found here, which I'm assuming is what I was using as my flag. So pretty much as I'm going through, this would be my flag to tell me to stop because I have found that second occurrence. And I have in past frequencies. So things that I have already gone through, and I know these don't matter because I've already gone through them. So I used a while loop in this sense, and I said, while I have not found this duplicate, while I have not seen this second occurrence of a specific frequency, do what I'm about to do in here. So let's see. If my counter is equal to the length of my input, my breakdown that I've cleaned, then I am setting it to 0. So what I'm doing here accounts for this scenario right here. And what this means is we have reached the end of our input. And when that happens and you have not found a second occurrence, you start over again. You start from the beginning. So you pretty much, you go all the way to the end and then come back around again. And that was this was my implementation of doing that, to pretty much say, if my counter is at the maximum amount of items in my breakdown length, that means I'm at the end. That means I need to start over again. So this was my way of looping back around. I set my counter back to 0. While I'm doing that, I do something very similar to what we did in my first solution, which was I have my current frequency, and I'm doing what we did before, which was adding it or subtracting it to the current item in my breakdown. That's here. And after I have done that, I have to do a check after every time I have done this, right? So I get my input. I know I'm not at the end, so I continue on. I add or subtract that, and now I have a new item. Now that I'm here, I'm going to either update this duplicate found to say this number I have seen before, or I'm not going to update it because I have not seen it before, and I'm going to continue on my merry way. So the way I did that was I have my past frequencies. So this is everything that I have been going through, and I'm using includes. So I'm basically saying, in my past frequencies, have I seen this number? The current thing that I have just added or subtracted, have I seen this before? And if I have, that's going to set that to true, my duplicate found flag to true. I'm going to push that item that I found. I'm not going to stop it yet, just I want to add that in there. And that might not be something we need to do, or it'll be a different implementation. This is the way I've found that has passed my test. So, so I will push that current frequency in case it's not. So let's say it's not. Let's go that route. So I'm going to check for what I just added. If it's in my past frequencies, cool, switch my duplicate found to true. If not, keep going. And with that, I have to keep track of all the numbers I have already seen, because how else am I going to know I've seen it again? So if it does not match and I've not seen this before, simply push this into the past frequency array, iterate through, and repeat the process. Keep going through the rest of my input until this duplicate found flag is true. And when that happens, I return the current frequency I am at, and with fingers crossed, that's the one that my puzzle is looking for. So that's what I did, and for me, for this input, it was 80,598. And once you get there, you get this cool little message here. Both parts of the puzzle are complete. They provide 2 gold stars, and that makes me really, really happy. It makes me want to do it again. So you'll see here, I apologize, I don't have the full picture because I couldn't go through all 25 days. But as you solve each day, you get a little part of the full picture. And it's a little bit more incentive for you to continue on, to keep going, to say, well, what's the picture going to look like? And it changes a little bit each time. So yeah, so that's day 1. Does anyone have any questions at all?
Can we see day 7?
Sure. That's kind of embarrassing. I don't think I even solved it.
You're still learning.
Yes. So yeah, I had day 8, but I didn't have anything in there. I'm like, I'm so stuck on day 7. Let me just prepare day 8.
I have a question.
Sure.
So is the concept of advent of code would take the same puzzle and replicate it for implementation in different language so you can learn cross?
Yes, I think he talks about it. I don't know what his intent was, but he basically made 25 puzzles, and you use whatever you want to solve them. So for me, I took this as an opportunity to learn JavaScript to solve these puzzles. Does that answer your question?
Almost. Maybe I'll ask you another question.
Sure.
When you are doing your implementation of solution, can I see it?
Yes, this is what we went through. So this was my implementation of the first day, the first day's puzzle.
So no, but like a guest can see it. Read your code, learn from it, implement it in different language.
Oh, yes, yes. I think I understand. All of my solutions are available on my GitHub. So you can see it, you can clone it. Are you talking about the puzzles themselves for Advent of Code or my implementations?
Code to read, like let's say that I want to learn a new language. And I want to see how a puzzle I already solved in one language.
Yes, yes. I'm sorry. Okay, I understand. Yes, I believe if you search Advent of Code in GitHub, you'll have, not here. So you'll see anyone else that has shared their solutions. Some people have done it in Rust. Some people have done it in.
But we're working on the same problem.
Correct.
So
for this, yes, for this year. So you'll see here, if they follow the naming convention, these are 2017's puzzles. These are 2016's puzzles. And this person did it in Python. So in that way, if you want to find a language you're more familiar with, or you want to see how it's implemented in a different language, definitely search Advent of Code on all of GitHub, and whoever uploaded their solutions is one way to find it. Yeah, so you'll see here, there's Python. Yeah, you'll see somebody did it in Rust, someone did it in Haskell, someone did it in C++, Elixir. You'll find somebody. And yeah, whatever they have uploaded here, you'll be able to find it in those particular languages. So that's the guy that made it. He's pretty awesome. He's the, so a lot of people have asked him or tried to give him puzzles to add, but I think something happened where he's like, I'm not doing that anymore because of law issues. So he's like, nope, every puzzle is going to come from me. It's only from my mind. There's no cheating. Not even his friends are allowed to know or get a head start on what his puzzles are for the next year. So that's the guy that made it. You're going to see it. And back to what you were asking, Dave, which was day 7. Oops. Maybe you guys can help me figure it out.
I got a question.
Yes.
Did you say there's a total of 25 every year?
Yes, so as long as he keeps going, which it seems like it, he has a lot of sponsors. So you'll see here, year 2018, I'm expecting, unless he shares on Twitter, he's not doing it anymore. Every year, starting December 1st, he releases them at midnight. And it's like something I get really excited about during Christmas. Super nerdy. But I get excited about it. This is one of the reasons I get super excited for December. And during the off time, I should be practicing the ones that I didn't finish. But again, work and life and all that's happening.
Writing a book.
Writing a book, yes. So day 7, I got the first part. I'm even surprised that I got the first part. Let's see what's happening here. So let's see. Oh, here we go. So again, a lot of backstory, which I like. It's a lot more fun to read it versus, sometimes HackerRank, it's like, here's the problem. What is it? So here it gives you a little bit of a story. So here, I guess it starts from right here. So instructions, you get a set of instructions. Instructions specify a series of steps. And like everything else, anything that's kind of important, he'll put some emphasis on. Instructions specify a series of steps and requirements about which steps must be finished before others can begin. That's your puzzle input. Each step is designated by a single letter. For example, suppose you have the following instructions. And can you guys read that? So these are your steps, and this is like a very small subset of what should be happening. So step C must be finished before step A can begin. Step C must be finished before step F can begin, so on and so forth. And they're so kind as to show you visually what that looks like, what the proper order of steps should occur. And this didn't, I mean, this kind of helped me, but this did not really help me when I was solving this.
That should be finished before any all else is first.
Right. So that's again, they do this in every puzzle where they try to give you examples and they try to push you in the right direction of this is how it should be solved, or when you're iterating or when you're going through your solution, these are the steps that you must make sure are happening so that you can get the output that you're looking for. So even more rules. Your first goal is to determine the order in which the steps should be completed. If more than one step is ready, choose the step which is first alphabetically. That's a lot going on there, right? In this example, the steps would be completed as follows. And this is pretty much matching to what you get here and visually. So in this example, the correct order is C, A, B, D, F, E. So now it's my turn to figure that out. And again, you cannot brute force this. Let's see what my puzzle input looked like. There we go. That's my puzzle input. So, you know, I wonder if I still have it. So I think I did use a visual representation. I put up paint, and then I did like circles with the letters, and then and arrows, right? And as I was implementing my solution, I would like I would fill it with red to say this is already done, to kind of indicate to myself, don't worry about this one, and put green on something else. And I vaguely remember, this was last year, mind you, that I used some sort of diagram to help me figure this out, because it was very difficult to just kind of iterate through this in code and keep all of those requirements in my head. So, oh, I actually got the first one. Okay. So let's see what my implementation was. Some of its parts. Steps. Ooh, yeah. All right, let's see what I did here. This is day 7, right? Yep. So again, bear with me. I'm going through old code and I'm figuring it out just like you are. So I have a function called steps, takes my input, which is all of this. Same thing, split it line by line, new line. I have final order and I have all steps. And final order because that's our output, right? That's what we have to put in to hopefully get the right answer. And I was kind to myself. I had a comment. Prepare parent-child relationships. This is a fairly complicated for loop I did here, so it ends here. All right, so let's see what we did. So for every step that I have, let's set the step that I'm working with. So the first step here. I had some match groups. Let's see. So I'm matching the group here. What am I doing here? Oh, I am doing the words. Does anybody remember? So I'm getting the match groups for the instructions. And since each of these are pretty much the same except for the letters, the steps, I believe that's what I was doing. I was using a regular expression to capture the different parts of each step, pretty much saying the only things I care about are the letters. Z must be finished before B. X must be finished before D. Everything else, the step must be finished before step can begin text, I don't care about. So those are my match groups. And I did parent and child, and I believe that's, let's see, match group, the second one. So that is saying for the groups that I have matched, so now I have split up each new line into a specific match group, probably step. The word step is a single match group. The letter is a second match group. The rest of the words are another match group. And the other letter is a match group. And I know because of the way the input is, and I double check this, all of the first letters must be finished before the second letter. So that I considered to be the parent. I said this one had to be done first before the next letter I found in my match group. So that's what I did. So I kept track of that. And I said parent would be the second letter, or in this case, at the second index is probably where my parent letter is, and at the 8th index of my match group is where my child step is. So now I know my parent, now I know my child. And let's see what I'm doing now. So in all steps, what is all steps? Which is currently empty right now. In all steps, find the step that is equal to the parent. And when if I do not find that, I apologize, exclamation point. If I don't find X in step, push that to be the parent and the children and the parents. And then if I go in all steps, find the child, step is a child and parents. So I'm preparing parent-child relationships. Oh, okay. So I think what I did here is, as I'm now preparing, keeping track of who goes before who, which parents have to go before which child, I kept track of this by denoting which step it is. So if it's the parent or the child, and then adding whether or not it has children and whether or not it has parents. So same thing here. If it's a child, I want to know if it has any other children or if it has any other parents above it. And I believe this is important for the next part. I'm not sure yet. So this is parent-child relationships. So I believe this was my way of doing this. This visual implementation is a way for me to quickly say A. So let's say if my step A is the one I was on right now, with this object that I've had, I would know C is a parent and I would know B and D are children. And knowing that in an accessible way, and by accessible way, meaning I know what kind of step it is, I have an array of children to work with, and I have an array of parents to work with, that makes it easier for me to do what I'm doing onward. So any questions so far? Have I lost anybody? I've lost myself, so.
Are you thinking of this as like a linked list thing?
Yes, so that's the thing, right? Maybe I'm implementing it, I don't know.
Okay.
So anyone that knows, if this is how you implement it, cool. It sounds very familiar to it, right? Because you have a node, you have a head, you know which one it's pointing to, which one is back. So I'm probably implementing a linked list and I didn't even know it. So that's why I love this. Okay, so I did that to fulfill the goal of knowing which ones are my parents, children, and parents. So prepared the parent-child relationships. So now, const parent relationship, all steps fine, the parent, and now I'm looking for, within my parent relationships, children. If it does not include the child, push this child into the parent relationship children. And then for a child relationship, if I find that, out of all the steps, find the child. If I don't find the parents in the child relationship, then push the parent into that child relationship's parents. Whew. Let's see. Let me see why I did that. Const parent, this is where a comment would be helpful, right? I implemented this in December. No, let me see. Why would I need to do this? And such is programming, right? I'm going back because I don't know. Let's see. First, yes. First goal is to determine the order. So I needed to know the parent-child relationships. Which steps, if more than, oh, that's probably why. If more than one step is ready, so the sentence right here. If more than one step is ready, choose the step which is first alphabetically. So, let's see. But that doesn't come down till here. So let's see.
That's why you sorted them down there.
I believe so, but that's tying to the sentence I just said. So I'm still trying to figure out why I did this. Let me see. Parent relationships, out of all the steps, find the step that is a parent. And then if if that parent relationship does not include the, I believe it's the current child that I'm on. Where's child? Where's child? Okay. This is step is child. Here. Okay. So include, if it does not include the child, push that child into the parent relationship. Well, I'm going to continue going because maybe I use it down here. Let's see. So I believe this is still part of preparing parent-child relationships. So now the actual part of iterating and going through. So reading this, it kind of makes sense, right? Even reading through it, it's very confusing to keep all of that in mind. You need to make sure it's in the right order. You need to make sure the ones that have to go before other ones occur. And then if you come up to ones that have multiple children, you need to make sure that the step that is first alphabetically goes first. So these are all different rules that we have to implement in code in order to get our output. And let's see. So let's see, let potential step. So I'm iterating through all the steps that I've prepared, all steps. And let the potential step, the current one I'm working with, I'm going to see, is this something that I think I'm figuring out the order right now as I go. I'm saying I called it potential step because I need to do a couple checks first to see if this is the next step right now or if I need to go past it and go to the next step and do the same thing. So let potential step equal, I'm going to filter by those that are not the parent's length, map by the step, why not step, and then sort it. Final order dot push, 1 second, let me see. Final order dot push, potential step, all steps, I'm splicing it, all steps, index of the step that I found that is a potential step. And then out of the all steps, I filter those that include the potential step, and then for each step, I splice it. Wow, I was a lot smarter in December. So let's see, let potential step equal all steps. So I'm filtering by those that don't have the parent's length. So I believe I'm breaking down the steps that I know are not the same at the parent level. And then I'm mapping each one to the step. And then I'm sorting it. Oh, I think this is where, okay, so I think this is what's happening here is as I get the potential step, I'm checking for the, if it has multiple children. And then as I get the multiple children to fulfill this step, which is if there's more than one step ready, choose the step which is first alphabetically. So I believe that's what's happening here is I am getting it, I'm sorting it alphabetically and then pushing that order in there in my final order. And all steps, so splice means we're taking a portion of that array, and what am I splicing? I am splicing where the find, so I'm finding where this potential step is. Okay, so out of the, okay, so all steps is the list of everything that I've prepared. Final order is the one that I care about. So that's the one I'm trying to keep pristine. So what I'm doing here is out of all of the steps that I have, I want to take a particular part out of that, right? Because from what I've filtered up here, I know there's one part of this entire order that I've figured out. And when I figured that out, I want to take that out of the all steps. All steps is unsorted. All steps is just prepared in the parent-child relationship way, nothing else. Once I figure out where I think it's going to be, I'm splicing it. I'm taking it out of the all steps at the index, so at the position of where I found that step. So out of this entire big, so out of here, where I've condensed it down into the parent and child relationships, out of this is considered my all steps. This is where everything is. It's out of order. Well, it's in the order I received it in. And from here, I'm plucking it out at whatever position it was in. So the index of, find the potential step. So potential step is the one I'm working on. So let's say that's, let's say it's this one, E and W. So let's say my potential step is E and W. And for the logic that I've sorted through, I know that this is the one that I want to add to my final order. I'm going to find that potential step. I want to find where my step has that parent and child. And when I find that, I want to know what position that is in. So in this case, if I'm looking for E and W, I have no idea what position this is. Get the position for me from here in my all steps. And out of that, take it out. So splice, you need to tell it where you are about to pluck that piece out. So figured that out right there. Splice that out. So you take the potential step that I think will be, I'm confident should go into my final order. I take that step and I take it out. So that's what I'm doing. I'm taking it out because the next time I iterate through and I go through my all steps, I've already used this portion. I've already said this step has been put in my final order. I don't want to duplicate it. I don't want to get confused with myself that I haven't used it yet. For what I've done up here, I know that this portion needs to go into my final order. So that's why I have removed it. That's why I'm splicing it. I'm taking it out of all steps. And then after that, after I've removed that, I now filter for where the parent includes the potential step. And for each, out of the ones I've filtered, take the parent's, splice the index of the potential step. Why am I doing it twice? Let me see, filter, potential step for each, splice it of the ones that I found. So I'm just gonna go through what's happening here. Maybe. So out of the all steps, I'm filtering for where the parents include the potential step I'm working with. And then out of the ones that I found that match this potential step, that include where the parents include the, okay, now I know what I'm doing. So filter, so we're filtering by the parents at this point. So you'll see here when I was finding just the step that included the potential step. Now I'm diving down further, probably into the parent-child relationships that are happening here, right? Because one parent can have multiple children. Yeah, that's pretty much it. So out of that, I'm filtering my steps to look for parents that include the potential step I'm working with. So if we continue with our last example, I'm looking for the ones where the parents include E and W. And then if I find any of these steps, for each of those steps that I find that fulfill this expression, I'm going to remove that potential step from the parent. Again, doing the same thing here, because I am confident that this potential step that I'm working with needs to go in the final order. What I'm doing here in these two here is cleaning up my all steps so that the next time I go through it and I go and filter, or I'm going and finding and searching where this position is, I don't confuse myself. I know I've already used it. So just as I have taken this step out, I've spliced it out of here, I'm doing the same thing in the parent, so wherever these potential steps are in the parent, I iterate through that parent. And remember, my steps here, they're arrays. There's an array of parents and there's an array of children. So what these are doing here is, for the potential step I'm working with, I want to take that out of the parent until all of them are gone. So if this had multiple, what this step would be doing is looking for the one that matches, taking that match, taking it out of that parent-child array right here, out of here. that splice would be taken, well, in particular the parents one, because we're working with the parents one, it would look in that parents array, it would take it out because I know I'm about to put it in the final order. It's not an unknown anymore. It's now, I know this belongs in the final order of what my puzzle output needs to be. And I need to clean up the existing ones, the existing unknown ones, right? So that's what that means. To find the parents that match the potential step, and then for each of the ones that I find out of the parents array of that step, take out, splice, take out where that step is in that array. And after iterating through all of that, that should return the final order. By coming this way, so what we're starting from is a really large list of steps. And depending on the rules that we have established, which was some have to start before others, some might have multiple, and if that's the case, start the one that's alphabetically first. Out of doing all of those steps, we have to remove the ones that match that, and then go through the entire list again. So we go through the list, we run it through these rules that we have, and if it matches, take that out, put it in the final order, and then go through it again. And it's pretty much sorting a list of steps there to create this final order. And that was the way I implemented it. Thank you for bearing with me, for helping me figure out my code again. But yeah, that, as you can see, this day 7, let's see here. If we go back to my commit history, you'll probably see a huge lag on 2018 once I reach day 7. So let's see, December 11, where's 7? Oh no, that's 5, 6. Yeah, it's very light. Anyway, it's that's day 7's. That's day 7's puzzle, and I believe I got it. That took me a very long time. As you can see, while I was going through my code with you, it was even very, I could have probably written it better. This is why I like this, and this is why I'm sharing it with you. You know, I'm a little bit embarrassed because I don't remember what I did, but after talking through it with you all and having all of you staring at me, it forced me to remember what was happening. But that's the cool thing about this, is that I'm not pretending to know everything. I'm using this as a way to get better. And hopefully, for 2019, I can get past day 8. That's really my goal right now, is I made it up to, I don't even know if I have a solution for day 8. Let's check. Memory maneuver. Did I start? Nope, didn't even start. Let's see what the day 8 was.
Did they get increasingly harder?
Much harder. I mean, based on your experience, I mean, if you were seeing me struggle through this, you're like, oh, this is easy. It gets much harder, trust me. But yeah, I think it's a great way to really challenge yourself. Clearly, day 8 was where I stopped. Let's see what's happening here. And I feel like this is because I did not have a formal data structures and algorithms background for my degree. I'm pretty sure if I had learned this, maybe some of them would be easier. I'm not saying it's guaranteed that I would do this like that because I had that background, but because I know I did not have that background, I know that I struggled with it a little bit more because, you know, it didn't come to mind to me that, oh, linked lists is what I have to do here. That's exactly what I need here. And someone who has that background might know that a little bit faster. But yeah, you can take a look at day 8 here. Let's see what we got to do. Tree is made up of nodes. A single outermost node forms the tree's root. This already sounds something like something I had to implement that I did not implement. And it contains all other nodes in the tree, or contains nodes that contain nodes, and so on. Specifically, a node consists of a header. Does this sound familiar? Which is always exactly 2 numbers: the quantity of child nodes, the quantity of metadata entries. 0 or more child nodes are specified in the header, 1 or more metadata entries. And they give you a nice visual example of what they mean for that. Bless you. So in this example, each node of the tree is also marked with an underline. starting with a letter. Okay. A, which has 2 child nodes and 3 metadata entries. The first check on this of the license file is to simply add up all of the metadata entries. In this example, that sum is this. Do I even want to know what my input looks like? That's my input. So please feel free to try it out. I'm actually gonna, after tomorrow's, I have another meetup to go to in Irvine, if you guys are in Irvine. After that, I'm actually going to try to finish day 7, since you've refreshed my memory tonight. But yeah, this is day 8. I mean, I can show you, let's see what day 25 is, because I have not gone there. I don't even know, oh, it is unlocked, okay. Let's see. This is like the big hurrah. That is, you reach to help, looks up at you. Story, story, story. You'll need a list of fixed points in space-time. Okay. Just need to align your device to the constellation of fixed points so that it can lock onto the destination and open the portal. Let me look up how much hot chocolate that breed of reindeer needs. All right, so you have a fixed points in space-time, your puzzle input. It's a set of 4-dimensional coordinates. I already see that down here, 4-dimensional coordinates. To align your device, acquire the hot chocolate, and save the reindeer, you just need to find the number of constellations of points in the list. So this is probably our puzzle answer. 2 points are in the same constellation if their Manhattan distance apart is no more than 3, or if they can form a chain of points, each a Manhattan distance. Is everyone familiar with Manhattan distance?
No.
That's the shortest distance between 2 points, Manhattan distance. Manhattan distance of a point and a line. So the distance between a point and a line, so the smallest distance. So this tells me you can find probably an equation that implements Manhattan's distance, and it's probably going to be a part of your solution. So that's Manhattan distance, the shortest distance from 1 point. So 2 points are in the same constellation if their Manhattan distance apart is no more than 3, or if they can form a chain of points, each a Manhattan distance no more than 3 from the last. And again, these types of things, I have to reread several times to make sure I understand it myself. So I think I understand what's happening. I know Manhattan distance is in there somewhere. I know that the max is no more than 3, but once you get into the code, I reference this, I go back and forth, and I keep rereading to make sure what I've implemented is actually what it's asking for, because most of the time it's not. And even reading it here right now to you, it's still a little confusing. It takes time to break it down. So no more than 3 from the last between the 2 of them. So luckily they give you some example, and sometimes this is helpful, sometimes it's not helpful at all, and it makes you more confused. For example, this, in the above list, the first 6 points form a single constellation, 0, 0, 0, 0, okay? It's exactly distance 3 from the next 4, and the point at 0, 0, 0, 6 is connected to the others by being 3 away. So I believe what that's trying to say is this, 0, 0, 0, 6 is exactly 3 from the next 4. 3. 1, well, that's more than 3, unless this is counting these 3 as the 3. 1, 2, 3, or the other way. See, I'm not understanding the question. That's what I thought it was. The point at 0, 0, 0, 6 is connected to the others by being 3 away from 0, 0, 0, 3. Okay. Which is already in the constellation. The bottom 2 points, 9, 0, 0, 0, 12, 0, 0, are in a separate constellation because no point is close enough to connect them to the first constellation. So be my guest. You guys can read this. I'm not going to even try to attempt to tell you.
My approach is very simple. First of all, I define the terms.
Yep.
What is a point?
Correct.
Okay. Is a point a sequence of 4 digits?
Yep.
What is a constellation? And then, at least now when I read it, I don't have terms that I don't understand, right?
Exactly. So, yeah. We are low on time, and my battery is about to run out, so I'm not going to do that. But Again, so I hope what I really want everyone to take away from this, if this is the last part that you're listening, is this is a really, really great way to challenge yourself. It's a gamified way, a fun way to really collect those stars. And the types of puzzles here, they may be similar in terms of what they're looking for to like hacker rank puzzles or leet code puzzles, but I think adding it into the story makes it a little bit more interesting. And I think you should all try it out. That's all. That's pretty much what I'm trying to say. They get consecutively harder. It's a great way for you to really, even the code that I've written before, I can go back and optimize that. Maybe not use a while loop, or optimize that to be a little bit cleaner, or maybe I add some more comments in there so that the next time I give this presentation, I'm not figuring it out with you. But it's a really good way. It has definitely helped me step up my JavaScript game in the sense of, again, knowing what map is, what filter is, what includes, what all the different methods are available to you in JavaScript, and to actually apply them in a cool way. You don't get to use these types of puzzles, at least for me, don't exist on a platform where it's like a simple CRUD app. You gotta create some things, delete some things, make sure some things pop up, click some buttons. I don't get that kind of puzzle or that kind of critical thinking that I do with these puzzles. So I hope, yep.
Is there some benchmarking to compare yourself with others?
Yes.
Like least number of lines?
There may be simple ones. So this is the overall. There's a leaderboard, and the way you get on here is you get points for being the fastest one to solve these puzzles. So they release every day at midnight. And I'm telling you, the moment I read through it, there's already people who have answered it. And I don't know how that's possible. Maybe for the simpler puzzles, sure, I can see that. But for something like this day 25, there are people answering it within maybe like 8 minutes. To me, that's very impressive. I don't have that kind of skill to get it that fast, but that's kind of like the worldwide leaderboard. So these are the points. From how many minutes the puzzle was released, you get certain points. The closer you are to release, the faster you are, the more points you get. And then there's also, if you want to just, there's private leaderboards. Here. Private leaderboards and your own personal stats. Let's see what my personal stats are. That's how long it took me. Over 24 hours. Because I probably started them after I came home from work the next day. So, like.
There's no way to say if somebody has, like, I like the simple approach. The simplest is the genius. Right? There's no way to measure that.
Sure. No.
Question, no?
I don't think so. Not that I've seen, not explicitly, but I'm sure you can, like, if you see all the different implementations, when you search for Advent of Code, all the other people have put it on there. I'm sure there are benchmarking tools that you can use that uses someone's implementation versus another, and I'm sure there are tools that says this is faster, or I don't know, or if you're in a private leaderboard, or if they get on the leaderboard before you, maybe it was faster, but no, I don't think there's an explicit way. And that's all very subjective. Like you said, the most elegant way is one that you can understand, or one that's simple. Or for me, if I was able to understand my own code, that probably would have been the better way, which I did on the first one. But the other one, I could probably refactor a little bit more so that I understand what's going on. I'm very much of the notion that human readable code is much better. And tonight proved that.
You did understand it.
I did. It took some time, and you guys struggled with me. So thank you for being patient.
Something very unique. You dare show us your code. That's very commendable.
I appreciate it. Like I said, I'm no expert. I want to get better at it. You should have seen this code way before. It was like for loop and for loop and for loop and everything everywhere and console logs everywhere. It was a mess. But this is the GitHub polished version. Because I said, I know I'm going to be sharing my solution, so let's clean it up a little bit. But I appreciate that. Thank you.
Thank you.
And that's it. So hope you guys enjoyed that, and I hope you try it out. If not tonight, sometime closer to Christmas, because new puzzles are out December 1st. So thank you. And pretty much,
Yes.
if you want to see more from me, just my website's adrienne.io. Everything's on there. All my socials are there. Feel free, if you enjoyed this, tweet about it. I would appreciate it. And then if you want to learn more about me, it's all there. I am actually going to speak at a couple other things. So I'm speaking at, I think this is Nebraska. I've never been, yeah, Nebraska. So I'm going to Omaha to speak there about JavaScript. Mine is Delicious JavaScript, Delectable Explanations of the Power of JS. So if there's one thing you know about me, it's I absolutely love desserts. I have a sweet tooth. And when I would try to teach JavaScript to my coworkers, they would always have difficulty with it, whether that's because they're new, whether that's because they're fully involved in like backend C# stuff and haven't touched JavaScript other than like jQuery. They always have difficulty. So what I hope to give in my talk is dessert-based explanations of how these functions work. And yeah, you can see all of this. I'm speaking at a couple other places. If you're in San Francisco, I'd love to see you there. I'll be there for Write Speak Code, and I'll see you after this. And awesome. And then I'll be in Croatia for WebCamp Zagreb. For there, I'll be talking about conducting humane code reviews. Yeah. So yeah, feel free to check me out, adrienne.io, and then my book is there, social's there. Thank you very much for bearing with me for 2 hours. I hope you enjoyed it, and I hope you check out Advent of Code. So thanks.
All right, one more round of applause, please. All right. Yeah, you're wonderful. Thank you again for coming out to JavaScriptLA. If you liked what you saw tonight, please tweet about it. Please go on social media, talk about your experience here. That's how we grow. That's how we get